In this section, we're going to start working with square roots, cube roots, and seeing how they operate on Desmos. Before we dive in, let's just throw in the relevant vocab words for this section. And they are the square root, perfect square, radical, and cube root. We'll table the cube root for in a minute, but let's look at our first example or our first definition, and that is a perfect square. So how would we define a perfect square? Well, the definition of a perfect square is the product of a rational number multiplied by itself. So what does that look like? Here's an example. If I had the number 7 and I multiplied it by itself, so 7 times 7, which we could also write as 7 squared, is 49. So by definition, 49 would be a perfect square because it is the product of a rational number multiplied by itself. 7 squared, 49, so 49 is a perfect square. I could do the same thing with negative 1.3. If I multiplied negative 1.3 to itself, that leaves me with, and remember, a negative times a negative is a positive. So 1.69 would be an example of a perfect square. And you'll notice your perfect squares will always be positive because you're taking the same number and you're multiplying it to itself. So let's look at our definition then for a square root. So you'll see right here that we've got the definition already written out. By definition, a square root is one of the two equal factors of a number. So let's circle back to the 7 squared equals 49. You'll notice that the factors of 49 that we used here are 7 and 7, two equal factors. So we could say then that the square root of 49 is 7. And that brings our radical in. We use that radical sign. We learned that in the last vocab section. The square root of 49 is 7. And hopefully you remember that this is called the radical, but we can also refer to it as the root. That's the square root symbol. So you'll notice this blank here, it's 81 is a blank because the square root of 81 is 9. Because the square root of 81 results in this whole number that comes out, we could then say 81 must be a perfect square. So let's look at these examples quickly, and then right after that you will do a couple of examples on your own. So for number 1, it's asking to find the square root of 25. So you'll notice on Desmos, right here at the bottom row, you'll see the radical symbol. And so that's the first thing that you type in. Followed by, inside the radical, 25. And then you'll see right below, we've got our answer of 5. Number 2, take note that that negative is outside the radical. Otherwise, we wouldn't be able to evaluate that. And if we have the square root of negative 144, we're looking at that result, and that is negative 12. I think maybe, oh, here it is. So 3 is similar. It's just you have a decimal. Let's look at 4. So 4 is 9/16. We've done enough with fractions that I'm hoping you're comfortable with hitting the radical, typing in 9, and then as soon as you hit divided by, it takes it into that, that fraction form and leaves us with 0.75. And we've also gone back up and hit the fraction symbol so that if we wanted, we could write that as a fraction as opposed to a decimal. And the last one is you type it like you see it. You type it like you see it. And so we've got root 147 plus 78 and leaves us with 15. Here we've got just a quick connection that tells us about irrational numbers versus our radicals that don't have perfect squares. So first, you have to know this. We've talked about it enough that our irrational numbers are decimals that are non-terminating or non-repeating. Now, how does that relate to our square roots? So if we have a number that is not a perfect square, that number will always, always be irrational. What do we mean by that? So square root of 16 is a perfect square because 4 squared is 16. So the square root of 16 is 4. However, the square root of 17 is not a perfect square. And so when we see those, that's going to result in an irrational number. So any radical that contains a non-perfect square will always be irrational. So we know perfect squares are when we have a number and it's multiplied by itself. Well, we also have perfect cubes, which then connects to our next and last piece, and that is cube roots. So let's first talk about our cube root notation, and you'll see it right here. When you have the radical symbol and you have a number in this place, it's called the index, but you don't really need to know that. But if you have a 3, and that's what we're going to be working with so far, that is defined as the cube root. So let's tie in cube roots and perfect cubes. Perfect cubes are when you have a number multiplied by itself 3 times. So here's an example. 4 times 4 times 4 is 64. So by definition, 64 is a perfect cube because 64 is 4 multiplied to itself 3 times. If I have negative 5 times negative 5 times negative 5, that gives me, what does that give me? So I know a negative times a negative is a positive, but then I have a positive times a negative. So that leaves us with negative 125. Negative 125 is also a perfect square, perfect cube, because negative 5 cubed gives us negative 125. So we are now bringing in our perfect cubes and our cube roots. So let's fill this in and then do a couple of Desmos examples, and then you'll try a couple on your own. So 27, we would say, similar to what we did previously, is a perfect cube because the cube root of 27 is 3. So now I can define my cube root as one of 3 equal factors of a number. What does that mean? That means if we took this example, I could then say that the cube root of negative 125 is negative 5, because negative 5 multiplied to itself 3 times is negative 125. Let's do some of these on Desmos. So before we start typing in our cube roots, the one thing I want to walk you through is if we're looking at the first of our slides for Desmos, the first thing we're going to do is we're no longer going to use the radical sign because that's only for square roots. So we're going to have to go here to functions. Then our next step, once we've gone to functions and we've highlighted it, we're going to select miscellaneous. And once we've selected miscellaneous, boop, 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 we're going to go here and choose the nth root. So now let's jump on Desmos and evaluate these. So you'll notice this looks a lot like what we were doing with the square roots. So if I'm looking for, let's do number 6. We're looking for the cube root of 8. So again, we're going to go to functions. I'm going to select miscellaneous, that's already highlighted, and I'm going to go to the nth root. Now you'll notice it's got my little cursor right above my radical, and I'm going to type in 3 and arrow to the right to get inside that radical. Now this is telling the calculator you're looking for the cube root. And then we hit enter and we're given 2. 2 is the cube root of 8 because 2 times 2 times 2 is 8. I'm going to modify question 9 just so that let's do the cube root of negative 216. So again, I'm going to go to functions, miscellaneous, and I'm typing in the nth root. There's my 3. I type in negative 216, and it tells me negative 6, because negative 6 multiplied to itself 3 times gives me negative 216. So I want you to try these.